All right, hello everybody. Welcome to our model framework walkthrough. I'm going to give everybody a taste of all of the different tools that we have available via the Credmark model framework. So currently, just to give everybody, set everybody's expectations a little bit, we're currently backfilling our production database. So currently the sort of historical ledger data goes up to sometime around 2020, somewhere in 2020. And we're pushing that forward. So we have some more of the future stuff on our development database, but for the purposes of this walkthrough, I'm going to be using our production database, which is a little bit in the past still. So that should be remedied really soon. And so there's a few things where you'll just see data from potentially before it was particularly relevant to whatever's going on now. So in this walkthrough, what I'm going to show you is how to become a contributor to the Credmark model library. So we're going to walk through kind of jump starting through forking the repository all the way through submitting pull requests to get your models on our production database. Currently, our production models are all available at gateway.credmark.com. You can go see our model documentation. These are the models that we've got running on production. So as you can see, there's quite a few. It can be a little bit overwhelming at first. But this we'll be putting up public links to our documentation on most of these, and you can see here that there can be contributor provided descriptions of all of these different models that you can then run on our production database. So gateway.credmark.com is where you can start to see all of these models that have been created. And at the end of this presentation, the idea is that when I submit my pull request and they all get pulled back in, they'll automatically be added to this list of models. So any contributor models will be publicly available kind of from as soon as they are accepted by the Credmark team. All right, so let's get started. So if I want to create a model, the first thing I'm going to do is I'm going to go to Credmark models Py. So this is our Python library of models. And I want to fork this repository into my personal GitHub account. So here's what I'm doing. I'm forking Credmark models Py. It should only take a few seconds. Here, now I have a copy of it. Credmark models Py 1. Fuck, it appended 1 because I already did this once. So that'll be, we'll just ignore that. Pretend it never happened. So I'm going to create, the next thing that I'm going to do is, got this forked. This is my local copy. This is forked from Credmark models Py. It's publicly available because the underlying repository is publicly available. And we are going to create a new window in my IDE. So here you can see here that I'm using Visual Studio Code. And then I'm going to start by cloning a Git repository. I'm going to go new Tectonics Credmark models Py 1. I'm going to do it in a new folder to walk through. So now I have a cloned repository with all the models in it that I am expecting. And here's all the Credmark models, here's all the example models, and I'm going to be contributing in the contrib folder. The contrib folder is where anyone who wants to contribute to the Credmark, contribute some models, they can do that in there. So the first thing that I'm going to do is open up a terminal because I want to install this now. All right, so I'm going to, you can see on the, in here, we've got all the quick start information here. So I'm going to execute that stuff in here. So the first thing I'm going to do is create a virtual environment. I'm going to start the virtual environment, and then I'm going to install the requirements. This goes pretty smoothly. Installing all the Credmark requirements, live coding demonstrations. Some of this stuff is a little heavyweight because basically everything that all the Web3 stuff is pretty heavyweight. Okay, while that's happening, I'm going to create a .env file where I'm going to set up my environment, and I'm going to use my local Alchemy node to run this stuff as I'm testing it. So there's my mainnet Alchemy node with my API key. Those are free at alchemyapi.io or something. So yeah, you can just search for Alchemy Crypto, and that should pop up there. Okay, the first thing I'm going to do is I'm going to list all the models that I can now play with. So I can hit Credmark dev list. That's our CLI tool. So that tool allows us to interact with the Credmark model framework. And you can see here, I'm getting a list that looks remarkably similar to our publicly available list because I haven't made any new ones yet. So these are the names of the models. Here's the versions that are available, or the most recent version number. And so as these things increment, that's how we say a version number has incremented. This is a brand new model. Ignore all the old stuff that was created from this model. These models are a logical element on top of the Credmark data. So first thing I'm going to do is, okay, so there's our list of models. Now what I can do is I can run an example here. So you can see that I'm using the CLI tool, Credmark dev. The command is run. The model that I'm going to run is example.echo, and I'm going to put in an input, which is always a dictionary that has message hello world on it. So let's see if this model runs. It does. Well, that is lovely and useless. Because that just essentially echoes out whatever I put in as the input. So hello world, we are up and running. So I want to start making a model. What I'm going to do is I'm going to make a place for me to have this model. So I'm going to make a directory in the contrib folder, which is for walkthrough. And then I'm going to create walkthrough models py as my place where I'm doing this work. So here's walkthrough models py. It's a fresh, empty Python file. First thing I want to do is I want to import credmark.model. So that is where all of our modeling stuff comes in. And then I'm going to need some types. So I'm going to import Credmark types. I'm going to be working with tokens here. So I'm going to import the token type. I want to make a model class. So first thing I'm going to do is create a class with a run function that imports our model. So we've got walkthrough model 1 here. It imports a model, and it has a run function that has this model. It passes in self, and it passes in whatever inputs. So right now, all this model is going to do is it's going to print hello walkthrough to the screen. So I can run that by doing Credmark dev run. Actually, wait one more second. First, I need to describe this model. So here's the description. This model. So here I'm describing it by saying the name of this model is contrib walkthrough 1. I'm working on version 1 of this model because no other versions have been deployed yet. There's no input, and it outputs a dictionary which has message hello walkthrough on it. So I'm going to say Credmark dev run contrib walkthrough. That's what I named it. So the slug is how you can execute whatever you want. Hey, there we go. We're running a model that I have contributed. We're there. I love it. So that's not particularly useful. So instead, let's change it up a little bit. Now the output of this model is going to be a token, and I use the address for wrapped Ethereum here. So what this is going to say is the output of this is going to be a token, so it'll automatically load in the token based on its address, and it'll print that as the output of the model. I need to save the file though before I run it. Hey, there we go. Look at that. It figured out that it was wrapped ether. The symbol is WETH. It has 18 decimals so that we can do math with it. And here's its address. I didn't call any functions on it, so it didn't load in its ABI. But let's assume that I didn't know the address for this. What I can do is symbol. So this is even easier to look at that. Figured out its own address, figured out its own decimals, and it knew that the symbol was WETH. So for wrapped ether, I can instantiate a token with that, and then I can do whatever functions that I want on this token. So great, we've got a model that loads in the wrapped ether, which is great. Now what I want to do next is I want to say, that's great, we've got wrapped Ethereum, but what I really want to see is the total supply of wrapped Ethereum. So what I've done is I've said this output used to be token, and now we want to do an expanded token. And this expanded token says I'm going to include total supply when I return this token. So there's already on the token object, there is a function called total supply because it doesn't take any inputs. We are able to do that. So it's pretty simple to just say, let's get what we had before, but include total supply in here. Now you'll notice that the ABI is loaded in automatically. So the ABI is this token has like a series of different things that you can do with it. Since I called total supply, I need to know what the ABI is in order to access those functions. So it loaded that in automatically, and you can see here that it has included the total supply, but this is a huge number. So this means that decimals hasn't been taken into account yet. So what we can do is we want the scaled total supply of this. And then when we run it, you can see here, it's much easier to read. We've got 6 million ETH in the total supply at, I don't know what block number. It's like 11 million or something like this. So there we go. There's some of the tools that you can use. That explains sort of the token tool and how you can pass in different data types in order to see different data types on the back end. Automatically loads in ABIs, so you don't have to instantiate crazy contracts. Very, very simple. If you've done any other Web3 work, you know what a pain in the butt it is to work with the Web3 library, because you basically need all the information about everything you're looking at up front. So I'm going to make another model. It's up here. Okay. So now I'm going to import the ledger data. The ledger data, we have token transfers on there. We've got all the receipts, and we've got the ledger model output. So what the ledger is it's basically all the transactions. If you go on Etherscan, you can see all the different transactions that happened. We've got those loaded up into a database, And we've got those accessible in a pretty simple way. So you can see here, first thing I'm going to do is describe my model to say this is our second walkthrough model, contrib walkthrough 2. The input is going to be a token, and the output is going to be a ledger model output. So you might be saying, what does this do? So here, what we're saying is we've done self.context. So the context is the execution context. That's saying, this is the block number I'm working on. I'm working on chain ID number 1 to be mainnet because the Credmark framework is multi-chain out of the box. I'm going to go get the ledger. So that's this tool where you can go and see all the. So that's the tool where you can see what has happened historically. And we've got a few different types of functions in there. This one will get all the ERC20 transfers. So what I want is the value column. There's other columns on here as well, where I can say token transfer table dot columns dot. I can do from address, log index, to address, token address, transaction hash, value. Right now, I'm only interested in the value because ultimately I want to find all of the WETH that came in and out of the WETH contract. So all the times we converted from WETH to ETH and ETH to WETH. And I don't know why it's pronounced that way, but that's how it's pronounced. And then I've got a where thing here where I want all of the values where that happened in the block number that I'm working on, self.context.block number. And that had whatever token I pass in, that address. So essentially it'll say, give me all the token transfers of some token during this block. Let's try it out. Let's see if we've got it. I need to pass in what I'm looking for. So what I can do is I can do Credmark dev, run, contrib, walkthrough 2, which is what I named my second model. And we need a token. So it's super easy to just say symbol WETH. So I'm going to define this token by its symbol. You can also define it by its address. You can define it by its name, and it will look it up on our backend and say, this is the token you're probably looking for. Symbol's pretty simple, but there are multiple tokens out there with the same symbol. So if it runs into a collision, it will let you know and it will error out. Addresses will never collide. WETH is pretty well defined. So there we go. We've got all the different values of every transfer in and out during this block. So you can see there must have been a lot of swaps happening this block because swaps have to convert ETH to WETH and back and forth. It's another reason that I chose this particular token for our demonstration. And these are the different amounts that were either converted into or out of WETH. So we're just looking at the whole volume. If I wanted to be more certain about that or pick one side or the other, what I could do is I could say, get me stuff where the to address is the WETH contract or the from address is the WETH contract. So I can do those kinds of transfers. So yeah, there we are on our second one. Now let's combine these two models so that I don't have to, so I could do wrapped Bitcoin here too, to run the same model on wrapped Bitcoin, but I don't know if there are any or not. There was a few.
Can I ask a question?
Yes.
So on one of those outputs, you got all those ABIs, and on this one, you did not. Can you explain like when that happens?
Yeah, so this is a token transfer because I'm not outputting the token object. So what happens is the token object will load in its ABI only when necessary. So if the token has to actually make a call to the chain to figure out something about itself, such as how many decimal places it has.
So basically like state data.
Yeah, so if it hits state data, then it will load in its own ABI and it will return that. But you can see that the data type that I'm outputting here is ledger model output. So this is just information from our ledger. So so I'm defining here what columns that I want in that.
Gotcha.
And yeah, so it makes it ugly for humans to read the output of this data, but ABI is super easy to ignore. And one of the nice things is that if I load up an ABI in one model and then pass it to the next model, then I don't have to go hit the database to load that. So you can see here that this takes in a token object as the input. And the only thing that I'm using from it is address. So the only thing I actually had to do since I said, go get wrapped Bitcoin or wrapped ETH is figure out using this symbol, what is the address so that I can look that up on the token transfers. But we don't want the modelers to have to do that work, right? So we do that work on their behalf by saying, you just pass us a symbol. What are you looking for? We'll load up the token object. And then depending on what you do with it, we'll pass that information on down the road. So if you hit total supply, you're going to need the ABI in order to hit total supply. So the ABI has to be loaded into the token object. So it's like everything is pretty context aware, but the modeler doesn't need to actually know any of that information. They just need to model. We want to get them to the math as fast as possible. So any other
Would it
questions?
be possible to show how to ignore the ABI, or is that just something that will
No.
happen?
No, that'll happen. It'll be in the output of a token until it no longer is. I know it's annoying to see it, but it'll be there if you used it, because we need a record of what happened. So since everything that we're doing is deterministic, we need a record of what ABI we used in order to make the data that you have consumed. So the next model that I'm going to do, I'm going to import something called a position. And a position is a token and an amount of tokens together. That's what a position is. So on this describe thing, we're going to create a new model called walkthrough 3. So this is our third model in here. We don't take in any input at all, and we output a position. Now, the first thing that we're going to do in this is run another model. So you can see that within my execution context, I can run other models. In this case, I'm going to run contrib walkthrough 1. What does that do again? That just returns WETH. I don't want to type that into my input, so we're just, all walkthrough 1 does is it goes and gets WETH. Cool. The return type is a token. So I can run that model within another model, and then I can go get all the transfers from the second one I did, contrib model walkthrough 2. So transfers on this block, self context run model, contrib walkthrough 2. What does it take as its input? It takes a token as its input. Well, since this went and got a token, why don't we pass it into the next one? The return type is going to be this return type. So that's all defined already. So we can check to make sure all this stuff is correct. And then what we're going to do is we're going to create a position where the amount is the sum of all the transfers. So this amount is actually the volume that was converted divided by token.decimals. Whoa, look at that. This is usually very difficult to figure out. Token.decimals, it'll just figure it out automatically. And the token we're using is this token. Then we can return this position. So let's hit our third model, which just combines the first two models to say, go get WETH, go get all the transfers that happened, and then sum them all together in a position object. Oh my gosh, would you look at that? It worked. The amount, since we already scaled it by its decimals, is 1900 WETH. So in one block, there was ins and outs of 1900 WETH for that block, I guess. That's great. We want to see this historically. We want to be able to graph this on the output. So we're going to make one final model that's going to graph all the WETH volume that happened during a block. So for this one, it doesn't take in any input. It outputs a dictionary. And what it's going to do is it's going to say, I'm going to use the historical tool. So here what we have is we can run any models we want anytime back in history. Can never look forward in history. So since the block number I'm working on is the most recent that we have in our database, it's somewhere in 2020 and we can only look backwards. So here I'm going to look backwards 100 blocks at intervals of 20 blocks each. So that should give me 5 results. Then when I'm done, I want to return the block that I'm looking at, the total supply, and the volume that I got from the walkthrough 3. So you can see here, the position amounts are on the output of this historical thing. And then since I'm returning this expanded token that has a total supply object on it, I can do token total supply. So then what I can do is I can compare the total supply as it goes up and down with the amount of volume that's happening on WETH. So I don't know if that would ever be useful to someone, but it illustrates both going and getting information from our database, going and getting the current token information with its total supply, and using the historical tool, all of which have to be made by hand in most cases. Did I copy the wrong thing? There we go. Let's see, I must have copied and pasted incorrectly. Yes, I did. There we go. You can see that our backfill not being totally up to date is causing a few problems, but here I can see the historical total supply and volume for each of the blocks that were created. So this is our historical outputs that that this thing ended up calling. Now, one of the most interesting things about this is, why would I ever, you might be asking yourself, why would I ever do all this work to create models for this company called Credmark? Well, the interesting thing about this is that we're going to be using this slug to create NFTs of each of our models so that we can have ownership over all of them. So you can see here I've included neilz.eth, which is one of my ENS names for one of my addresses. So when Credmark actually migrates all of this stuff over to using NFTs, we will have an NFT of every single model in here so we can ascribe ownership. So only you can change it. You can only change it if you own the NFT to that model, and you'll be getting Credmark rewards as soon as people use it. And you might be saying, well, how do you track who is using what? But you can see in the output of contrib walkthrough 4, it ended up calling contrib walkthrough 2 6 times. It ended up calling contrib walkthrough 3 6 times. It ended up calling something called series block window interval. That's this historical stuff, 1 time. And it called contrib walkthrough 4 1 time. So we are able to track all of the dependent models. So you can build models on top of models, and the people downstream will be getting rewards for having built useful models. Now I am done with my modeling. So how would I deal with this? Essentially what I'm going to do is I'm going to check in walkthrough models. I think actually include that I am the developer in all of these things. Okay, great. Copy pasting. So I'm going to check in walkthroughmodels.py, check in, check that in, and push it. So now I have contributed to my fork of this. Let's refresh it. Whoa, look at that. I've checked it in. Now I want to start collecting my rewards. So what I want to do is I want to hand this over to the Credmark team so that they can check my models and start. And when we launch these NFTs, I can start getting rewards. So then what I want to do is create a pull request. And this will alert the Credmark team that these models are in the queue. And that's that. So this branch has no conflicts with the main branch. So yeah, so I could merge this in right now. I'm not going to because these models don't really do anything useful. They're just for illuminating purposes. But New Tectonics wants to merge one commit from Credmark main into Credmark main from New Tectonics main. And this way, we can do all kinds of checks on the code that has been provided, and those will be automated. So that, my friends, is the Credmark framework. In the future, we'll be adding more documentation about how much time is saved to do these types of things. I ended up checking in, 68 lines of code. That would be almost impossible to do in 68 lines of code using other tools that are out there. It would probably be hundreds of lines of code, maybe thousands. So hopefully this makes the modeling experience much cleaner. Now, what we're looking for from you is feedback about how do our tokens work, or how do our tools work? Do they make sense? Over the next few months, we want to be collecting, models, but more than that, we want to be collecting feedback on the developer experience as you're using our tools. So yeah, go check out more of the documentation. It's here on the front end. See if that makes any sense. You can feel free to check out our current API offerings over here. Ask us any questions in the Discord. We're here to answer questions, and yeah, I think that's more or less it. Are there any questions that you have now for me that we want to put on this video? Cool. Cool.
Wait. Sorry, I have a question.
Yeah, moment.
So if I am looking to build a model on a protocol, can you briefly just describe like what steps I would take before I can get started building my model? Do I need to find an ABI? Do I need to find the contract address?
So as soon as our backfill is done, you won't need any of the ABIs. You will either need a contract address or the name of the contract you're looking for.
Okay.
In the future, we will also be labeling some of these things in such a way where I can say, get me all of, for example, Curve Finance contracts, and it'll just go load those into contract objects so that you can just start using them. So it's
very cool.
We're going to be using key value pairs that are like protocol, Curve Finance, product, V1. And then you can do things like, give me all the contracts that are swaps. Give me all the contracts that are gauges. And it will go and get not only those contracts, but the ABIs to all those contracts, and then load them in so that you can just start using the output of those contracts as you see fit.
Okay, cool. My last question is, just now when you were running these models, were you running it against a local model runner, or were you using our production?
I was using our production model runner.
Can
So-
you maybe show how to configure that?
Well, for the purposes of contributing models, we don't want people necessarily to have to run that kind of infrastructure on their end. So as soon as the
Yeah,
back-
I guess I was asking like, how would you point your model development to use our production? Or like the,
so you can see on the, did I close this? No, did I close it? No, I didn't. So you can see here that it's hitting our, when it's going and looking for how to calculate previous blocks, for example, in the historical stuff, it's hitting our gateway server. So this is running against our production infrastructure and our production database.
gotcha.
It's running local models.
I guess when you put the command in the command line, if you don't specify like hit a local one, it'll just default to production or default to ours.
Yeah, and there are things where if you are running a local version of some of our infrastructure, you can hit a local API, but that's mostly for Credmark development. That's not necessarily for model development.
Okay, great, thanks.
Mm-hmm. Cool. All right, people. That is it for me. Hopefully this is simpler than using the Web3 libraries, and hopefully this makes deploying your models to a production environment very, very simple, since all you have to do is a PR with just a few lines of code. Cool. Thanks, everybody. Go try it out.
Thanks, Neil.
Okay. My pleasure. See you later.